Hey Math 20-1 students, it's Ms. Schaub here. Today we are going to be trying something a little bit different. Hopefully you are watching this video on Wednesday night here, and we'll be taking up some questions and stuff in class tomorrow. So we're going to start by looking at 4.3, solving systems of equations by elimination. Our goal here is basically to be able to solve linear quadratic and quadratic equations algebraically through elimination. The first example that we're going to try is one of the examples that we went through last year. Here I have a linear system, and my goal through elimination is trying to eliminate or get rid of a variable. So if you look at this example, the y's have something in common. They have almost the same coefficient. In front of one y, or in front of one of the y's there's a 1, and in front of the other one there's a -1. So what operation can I do to eliminate my y's? Well, I can add those two equations together. So I'll have 2x subtract x is x, y subtract y is no y, and 2 plus 4 is 6. Thus I've eliminated the y variable, just leaving x is equal to 6. Now to solve for my y, I'm going to insert this x is equal to 6 into one of my original equations. Then I'm left with -6 plus y equals 2. Well, to isolate the y, I must add 6 to both sides, and I'm left with an answer of y equals 8. Now, when I write my final answer, I want to write it as an ordered pair, so my ordered pair is 6 and 8. That means that those two lines intersect at the point 6 and 8. So we're going to try and do a little bit more complicated of an example. If you notice in the following system, we do not have two coefficients that are the same, so we need to make them the same. So I'm going to multiply the entire first equation by 2 in order to get a 10x subtract 8y equals 28. Now I want to make this x the same, so I'm going to multiply everything by 5, leaving me with 10x subtract 15y equals 50. Now I must subtract those two equations, and if you recall, subtracting is just like adding all the opposites. So that might make it a little bit easier for you so you don't have double negatives. 10x subtract 10x is no x. 15 subtract 8 is 5y, or pardon me, 7y. And 28 subtract 50 is -22. Now, this wasn't a mistake. We are going to be left with a fraction. So the y-coordinate of the intersection point will be at -22 and 7. I need to then insert this value into one of my original equations to solve for x. I'm going to pick the second equation this time, but it really doesn't matter which equation you pick. It's whichever one you feel more comfortable with. So when I multiply fractions, if you recall, I go straight across. So I have 2x plus 66 over 7 equals 10. When I subtract fractions, I need to have a common denominator. So I'm going to subtract 66 over 7 from both sides. And 10 is the same as 10 over 1. So here I have 2x is equal to, well, 10 is equal to what over 7? 70 over 7. So I'm left with 2x is equal to 4 over 7. What's half of 4/7? Well, it's 2/7. So here I have the x-coordinate of my intersection point, the y-coordinate of my intersection point. So I'm going to write that out. And we need to leave our answers as exact values. So if that means leave it as a fraction, then leave it that way. If we have an exact value that we find using the quadratic formula, then you need to write it as an exact value as well. Okay. Now, this practice question, this is what we would like you to do for tomorrow. So we want you to try that. Now, if you feel pretty confident, stop us right now, do that question, come back, and if you're still not comfortable though, that's okay. Watch 2 more of these examples, and then hopefully you'll feel a little bit better. So continuing on in our notes, now we have something that's new. This is not something that we did last year. We're going to solve this quadratic system through elimination. So I'm going to start by subtracting my 2 equations, leaving me with 0 is equal to, you Here I'm just switching on my signs to make it a little bit easier for myself. Here I'm left with a really nice quadratic. Now, you know how I feel about the diamond method. If we are factoring, that is our preferred method. It's the quickest and it's the easiest. Factoring isn't going anywhere, guys, so make sure you learn how to do it. So here I filled in my side numbers, and I've left with two possible solutions for x, one at 10/3 and one at 1. Now I'm going to go through this x is equal to 1 first. I'm going to put x is equal to 1 into one of my original equations for x, solve for y. So I have y is equal to 2 times 1 squared, subtract 7 times 1, plus 3. So I'll have 2 subtract 7 plus 3. That'll give me an answer of -2. So I have one intersection point at 1 and -2. Now that wasn't too bad because I'm working with integers. When I'm working with fractions, I'm going to use one of the calculator features that I have to aid me. Now make sure you know how to do this algebraically. The calculator, it isn't what we go to all the time, it's just another resource. So I'm going to put my x is equal to 10/3 in as a fraction. You already know that 10/3 is 3.3 repeating. Now I'm going to store that in for x and press enter. Now if I type in one of my original equations, it will automatically insert that x value for me. I'm left with a repeating decimal. You know a repeating decimal is a fraction. So if I math frac it, I'm going to get a nice fraction of 17/9. So when x is equal to 10/3, then y is equal to 17/9. Thus giving me my second ordered pair and my second solution. So those two quadratics, they intersect in two spots. Now we got one more example here. The last example that we're going to do, it's a linear quadratic system. If you recognize right away, this first equation does not have an isolated y. So that's a good place to start. Now as a general rule of thumb, when we're doing elimination, and if you have a quadratic and a linear, put the quadratic on top. It's going to help you, or it's going to kind of prevent you from having a negative x squared value, which is easier to work with. Once again, I've just done some basic polynomial subtraction, and I'm left with a nice quadratic. I'm going to try and diamond it. It might work, it might not. Oh, look, it does. So I'm left with 0 is equal to x subtract 4 times x plus 3. So I'm going to have two possible x values, one at -3 and one at 4. Now before you go and store it in for x, this is not going to be the hardest example, so let's actually use this one, or use this first equation in order to solve it. So I have y subtract 2 times -3 equals 6. Well, -2 times -3, that's just like 6. So y plus 6 equals 6. What plus 6 equals 6? 0. So I have one intersection point at -3 and 0. And the other one, well, I'm going to put that 4 in for x. So I have y subtract 8 equals 6, add my 8 to both sides, and I'm left with y is equal to 14. Therefore, my other intersection point is at 4 and 14. So I have both my solutions. They're written as ordered pairs. There is one more example in your notes. It looks like such. Now, this is one of the questions that we're going to take up in class tomorrow because it's a little bit more challenging. If you want to try it on your own, though, that's not a bad idea. If you have any questions whatsoever about the ones that we went over, if you want to throw them in the comments at the bottom, Miss Tucker or I will take a look at it and we'll try and give you some feedback. So hopefully this was successful for you, and we can't wait to see you guys tomorrow. Have a good night.